Next topic is on task management. Task management, which represents the ADLC task or the task features, task creation, task stack, start checking, task deletion, change a task priority, suspended and resume a task, get information about a task. So this diagram shows the task management where it is to be created, the stack is to be arranged, and it goes to the MCU. The features of the task is a microcontroller OS2 can manage up to 64 tasks. The 4 highest priority takes the 4 lowest priority tasks reserved for one of its own use. The lower value of a priority, the high priority of the task. The task priority number also serves as the task identifier. A task, also called a thread, is a simple program that thinks it has a CPU of all itself. Each task is assigned a priority, its own set of CPU registers and own stack areas. This is the process cycle where it is to be new program is started and it is to be admitted, then it is to be get ready and it is to be waiting, and again it goes to the running and terminated. So the interrupt and the scheduler dispatch all are different same, which makes a link between the ready, running and the waiting process. So next is task creation. The two function of creating a task is there: OS task create and OS task create to exit. This is for an ready, running, waiting, idling and terminated, and it is to be used to block context also. So stack, task stack and the stack checking. To create the task we have to allocate some stack in the memory. The stack will be allocated in the memory of the processor. After the task is created, the task has to get a stack in which it will store its data. A stack must contain often continuously memory location. It is necessary to determine how much stack space a task actually uses of. So the task deletion. Deleting a task means the task will be returned to its dominant state, and it does not mean to code for the task will be deleted. The calling task can delete itself. If another task tries to delete the current task, the resources are not freed and thus all are lost. So the task has to delete itself after it uses its resource. And the task management, priority of the calling task or the task and the task can be changed at the runtime. A task can suspend itself to another task. A suspended task can resume itself. A task can be obtained information about itself or the other task. The information can be used to know what the task is doing at a particular time. So this is the kernel. The kernel is a part of a multitasking system responsibilities. When the kernel decides to run a different task, it is simply saves the current task context CPU registers on the stack registers. So this is also having the kernel which allows consumes CPU time. Single chip microcontrollers are generally not able to run a real time kernel because they have a very little RAM. Once you design a system using a real time kernel, you will not want to go back to the foreground background systems. So this is context switching of a task switching. When the multitasking kernel decides to run a different task, it is simply whereas the current task contents in the current task contains storage area. These processes called the context switch or the task switch. Switching adds overhead to the application. More registers a CPU has, the higher overhead. The time required to perform a context switch is determined by the how many registers are being used. So this is the diagram for the task 1, 2 and n, which is all connected with the CPU registers.